on page 308. This is in 5.2. This is kind of giving you some hints, getting you started on this proof, even though the answer's in the back of the book. It's got 10 steps to it, so it's going to be a long proof. You are to prove the converse of theorem 5.2, which has no meaning, of the perpendicular bisector theorem. Perpendicular bisector theorem says that if a point is on the perpendicular bisector, it's equidistant from the endpoints of a segment, and the converse would be if a point is equidistant from the endpoints of a segment, it is on the perpendicular bisector. So you're to prove that C is on the perpendicular bisector. Okay, so we're going to start, and then the hint in the book says construct a line through C perpendicular to AB, which they have already done for you in the figure. Okay, so your statements. And your reasons. You're going to start with the given, of course. So I'm going to let you write that down. You know it, so I'm not going to write it because that's giving you too much information. Then the next one said to construct a line through point C that is perpendicular to AB. So that's what we're going to say. Draw a line PC perpendicular to AB. And the question would be, why would we be allowed to do that? And we know that 2 points determine a line, but in this one we need even more than that. We need to make it perpendicular. So our reason for being able to draw a line perpendicular to AB would be the perpendicular postulate. Remember, the perpendicular postulate says there is only one line that goes through point C that is perpendicular to AB. So that would be the perpendicular postulate, which is similar to the parallel postulate, which says there's only one line through a point that is parallel to a given segment. Okay, now we need to prove, we're looking at these two triangles, we're going to need to prove that these two triangles are congruent, because what we're missing here is not the perpendicular part, that C is on the perpendicular, a line perpendicular to AB, but the perpendicular bisector. So we need to use the information that we have to prove that AB is bisected by point P. So we need to prove those two triangles are congruent to each other. Okay, so we are going to look at what we have. We have two sides that are congruent, and you've already listed that in your given. And we have a perpendicular line, so we have right triangles. So what are the ways that we can prove that two triangles are congruent? We've got side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Now, which one of those is a good opportunity to use this? First of all, these are right triangles, so it could be hypotenuse leg. Let's check it and see if we can prove that. If we look at APC and BPC, are the hypotenuses congruent to each other? Well, the hypotenuse is directly across from the right angle, so CB is congruent to AC, and those are the two hypotenuses. So hypotenuse leg means that you have to have two hypotenuses that are congruent to each other, and a leg that's congruent for each of those triangles. Do we have a leg? Do we know any other sides that are congruent here? Well, CP is congruent to CP, and you should know why. So can we prove that these two triangles are congruent by hypotenuse leg? Now, what are the steps? Yes, we can. So what are the steps that we need to use? Well, first of all, we've got to prove that they're right triangles. And I need to make a correction in my given statement. If you copied your given statement correctly, you notice that it said that it was equal. that the two segments were equal, not congruent, so we need to fix that. Okay, so we have to talk about congruence because we're trying to prove these two triangles are congruent. So, first thing we have to do is say that AC is congruent to CB. Why? That's the definition of congruence. Okay, how do we know that these are right triangles? Well, we said that we were going to draw PC perpendicular to AB. And what does a perpendicular line form? So we would say angle CPA and angle CPB are right angles. And how do we know that? Perpendicular lines form right angles, or you could use the definition of perpendicular lines. Okay, are they congruent to each other? Angle CPA is congruent to angle CPB. Why? All right angles are congruent. Now that is not a step that is listed in your book, but it is one that they sometimes require. So that's alright, we're going to stick it in there. That'll make it 11 steps. Make us look really intelligent. Okay, now, since those are right angles, what do we know about those triangles? Triangle CPA and triangle CPB are right triangles. How do we know that? Definition of a right triangle. Okay, let's go on with our hypotenuse leg thing. Okay, we've proven two sides are congruent to each other right here. The two hypotenuses, this is our hypotenuse. And we've proven that they're right triangles, so we can use hypotenuse leg. Now, what leg is congruent? Okay, using the reflexive property, you should be able to say alright, then what can you say about the two triangles? Alright, now that you know the two, and why would you say that? That would be the other thing. And then now that we can say that those two triangles are congruent to each other, what can we say about the parts? Which parts can we say that about? Since those two parts are congruent, what can we say about point P? And that would be by the definition of a midpoint. Now, I didn't finish the statement over there for number 10. You're going to have to do that. And then 11, we can state C is on the perpendicular bisector. And that would be by the definition of a perpendicular bisector.